Hello, everyone. Today is August 9th, 2023. This is the Kubernetes Data Protection Working Group meeting. I think today we don't have other things on the agenda. I think mainly we probably just want to do an update on the CPT cap. So Ivan or Carl, Prasad, if you guys want to talk about it.
Yeah, we've updated the cap with the feedback from the SIGOT team. I believe Prasad has updated his demonstration prototype.
Are you
Prasad?
going to share this or can make you a co-host?
Yeah, Prasad probably.
All right.
Yeah.
Go ahead.
Cool. Yeah, so based on previous discussion, I have updated the prototype. Yeah, I would like to show the demo and we can walk through the sample implementation. Yeah. So yeah, let me know. I mean, we can go through the design again if it needed on very high level, and then we can go through the demo.
Yeah, go ahead. You want to do it or you? Okay, I'm also making Carl, Ivan co-presenter. If you're not sure who want to present.
Prasad.
Yeah, I have shared my screen. Is it visible?
Yes.
Cool. Yeah, I can, on very high level, I can just talk about what we discussed last time. So so this is the new approach. I think I don't know how many iterations we had, but I guess it's 8th or 9th iteration. So the new, as per the new proposal, what we are doing is we are making use of token request and token reviews API to basically generate the token as well as validate the token, and to achieve the authentication authorization without having the extra controller we had in the previous proposals. So if I talk about the flow, how the end-to-end flow would look like. So the backup client would basically discover the snapshot meta service CR for the driver, and the snapshot metadata service CR contains the required information for calling the gRPC endpoint. So it has basically audience string, CS certificate, and address of the sidecar service, to which we'll be making the gRPC call to get the change block metadata. And yeah, so
what will be the audience string? Can you give an example?
Yeah, it could be any random string.
Or you could use the DNS name. I mean, really the characteristic of the string is it should be distinct and unique to the service. So using the DNS service name as a string could also be, a valid value.
Yeah, it can't just be a random one, right? Like if it matches another CSI driver somehow by coincidence, then it would mess up the authentication flow. So it has to be unique to the CSI driver. So one of the recommendations is the DNS name.
Okay.
But it's something that, if you imagine like user using a Helm to install it, it can be something that the user override, but by default we can, somehow extract it from the DNS name or something.
Yeah.
Yeah, it has to be unique per driver. That's right. Yeah, and we can decide on format. It could be DNS name as well to make sure that it's unique for each driver. Yeah, so once client gets the required information based on the audience stream, it generates the token. So backup client can use token request API to generate the token for the given audience. We can also specify the expiry time and bound object reference. once it gets the token, the next step would be calling the gRPC endpoint with the given params. So we have to specify the audience scope token we generated in the first step, as well as the other information like namespace, base snapshot, target snapshot, and the external snapshot metadata, which is deployed as a sidecar to the CSI driver, where the CSI driver, where we have the service provider implementation of getting the change block metadata. So the sidecar basically performs the authentication using the token review API. So it validates the token it has passed. It also validates if the token or the client identity that we received, that we kind of fetched using the token review, if that identity is allowed to access the volume snapshot resources. And the authorization we check using subject access review API. So basically, token review provides us user identity, and that user identity we use to perform authorization check using subject access review if the user is allowed to access the volume snapshot resources. Yeah, and then the client side, this communication will be obviously TLS. So the CS certificate we got from the snapshot metadata service, it used to validate server at client side. And yeah, that way we have TLS, as well as we have also validated client using token reviews and subject access reviews APIs. Yeah, once it's done, the sidecar calls the service provider implementation of CBT and streams the response back to the client. So this is the kind of end-to-end workflow I tried to summarize. If you have any questions around these, we can talk, but yeah, otherwise I can jump into the demo. I'm not sure which screen is visible. Right, should we jump into the demo then?
We're looking at your web browser with GitHub.
All right, cool. All right, awesome. So this is the repo where I have added all the prototype source code. In the README, I have also added steps like how to deploy this end-to-end prototype, and given an example how a sample client can be used to get the change block metadata. I'll talk in brief about the services. So we have external snapshot metadata service, which is deployed as a sidecar to the service provider.
Excuse me, your sample drive. So it's like a fake driver, or is it like a real driver that you're using?
Yeah, it's a fake driver for the sake of prototype. Yeah.
Okay, so that means you're not really taking snapshot, or?
We are taking snapshot. We are just mocking the get delta handler, basically. We are implementing the get delta RPC.
Okay, so the delta, okay, that's fake. Okay.
Yeah. Only that API. Otherwise, we are using, in this demo, we are using the host path CSI driver to create
so it is a real driver. It is a real driver.
Yeah. For snapshots, it's a real driver.
But the delta, because host path doesn't really know how to retrieve that, so you basically that part is fake. Is that what you mean?
Exactly.
Okay.
All right. So yeah. So as we see as we have already seen in the design, these two containers are these two services basically. This we see in the diagram. So external snapshot metadata is the sidecar to the service provider implementation, which is sample CSI CBT service. which mocks the get delta gRPC handler. And external snapshot metadata service is obviously responsible for proxying the call to service provider implementation sidecar and returns the response back. Also performs authentication checks using token reviews and subject access reviews. Right. So I'll briefly talk about the deployments. So I have I have a namespace CSR driver where I have installed postpath CSR driver as well as the external snapshot metadata service, which has two containers. One is the external snapshot metadata as well as the the get delta gRPC handler, or we can call it the service provider implementation to get the changelog metadata. And there is one more namespace, CBT client, where I have deployed a sample backup client application I will be using for this demo to get the changelog metadata. There is one more namespace called database, where I have created a PVC. So we can assume this as a application namespace where we have some applications installed, some databases installed. I have also created a couple of snapshots on the same PVC. So you can see there are like I guess around 4 snapshots created on CSI PVC. Okay, and I have created the snapshot metadata service resource for this driver, for the host path driver. Snapshot metadata. Oops. Right. If we view the content, or if we see the YAML manifest for this resource, we have added it under the specs. We can see it has address, audience. Obviously, this is I have used random string, but we'll have to we'll decide on the specific format. We can use the DNS names itself, and it also has CS certificate. All right, so yeah, so we can walk through the client now. What specific things client does in order to get the changelog metadata. So yeah, I'll first run the demo. Then we can go through the source code and figure out how the implementation would look like. All right, so in the
there's a question in the chat.
Sure. Can actually put a CSR directly into specs. I mean, is there any concern about? Yeah.
There's plenty of examples of. There's plenty of examples of CA certs being embedded in Kubernetes objects. They're not secret at all, so you just have to handle the encoding as the base 64 encoding or something.
Yeah, I mean, very common example would be validating webhook configurations or mutating webhook configurations, right? We specify CA certificates along with the endpoints there. All right, so what we'll do is we'll try to get the changelog metadata on for the snapshot that we have just listed. So I just I'll just execute to the CBT client pod. In the CBT, client pod, I have there is a CLI, I would say, which we have implemented. It takes base snapshot, target snapshot as a parameter, along with other information like client namespace, the application namespace, and yeah, about the token mount, we'll come to this in a bit. But yeah, so for these two pairs of snapshots, we'll try to get the changelog metadata. So base snapshot is this one. There's a target snapshot. The application namespace is database, and the client namespace, the backup client namespace is CBT client. And we have also mounted service account into the CBT into this pod, which is CBT client service account. And yeah, if we execute this command, what it does is it first discovers the driver name from the snapshot, right? Once it gets the driver name, it searches for snapshot metadata service resource for the driver. The driver is source path CSI character. So once it finds the snapshot metadata service for this driver, it gets the information like the CS certificate as well as audience and the address. For the audience, it creates the token request API, and in the response, we get the token along with the expiry time, obviously. And then we use all these parameters to call the gRPC endpoint, and this is the sample or mock changelog metadata information that we have implemented on this sample CSI driver, which is streamed back to the backup client basically. And if you see the logs of the external metadata service, right, so there are two containers. We'll go one by one. This is the external snapshot service, which acts as a proxy, right? Yeah, so if we see the flow here, it gets the request first with the token and other information, snapshot, base snapshot name, target snapshot name, and the max result parameter for pagination. So what it does is what the proxy service or the external snapshot metadata sidecar does is it first discovers the snapshot metadata service for the driver to fetch the audience stream. So once it gets the audience stream, it calls the token review API with the token it received in the request as a request parameter. And the audience we fetched from the snapshot metadata service. So token review basically validates the token if this token is valid for this audience, if it's targeted for this audience, right? So in the response, we get authenticate true. We also get the user information along with the username, the groups, and other information. Yeah, the groups it belongs, UID, and all this stuff. Also, it also returns the audiences that we can again validate against the one we received in the snapshot metadata service object. I guess this returns all the list of audiences for which this token is generated, and we can obviously match if it's generated for multiple audiences. We can it validates if the audience we pass in this request, if this audience string belongs to the list of audiences, if there are multiple, basically it matches with any one of the audiences for which it's generated. We don't have to go into that, but yeah, just I wanted to share that. Yeah, so once it gets the user identity, excuse me, it calls subject access review APIs to validate if the user can access to volume snapshot resources, and if it validated that, and then it tries to fetch the snapshot handles or snapshot IDs for the snapshot names. So it looks for volume snapshot resources, volume snapshot content resources, finds out the IDs, and then uses those IDs. I should have logged the request, how it calls the CSI driver's endpoint. But yeah, so based on the after converting the parameters, like after mapping the snapshot names to the ID, and it calls the CSI drivers gRPC endpoint to get the actual change of metadata, and proxies the response back to the client. And if you check the CSI drivers logs, so yeah, we can see here the request, how the request would look like at the CSI driver side, and it sends it sends back the response to the external snapshot service, and then the response is streamed back to the client. All right. So this is one way how client can generate token. There is another way as well. So using projected volumes, so client can either use token request APIs to generate token, or they can use the projected volumes to mount the service account token into the pod. So this way, we are basically this way the token can be generated by kubelet and mounted to the pod when we create the pod. So
it becomes a bound token. So when the pod dies, the token gets invalidated automatically.
Exactly. So if the pod is deleted, the token becomes invalid automatically. And client doesn't have to, call these all APIs to discover audience and create the token request API, create token and use that token, right? You can just read the token from the mounted path and just directly call the gRPC endpoint. So we'll quickly try that as well. So I'll create this backup pod in the same namespace. I guess we have already seen the specs of this pod. We are using the same sample client, in which we have a sample. We have a CLI, gRPC client CLI. It mounts the CBT client service account, and we are using projected volumes here to mount the service account token with these audience, right? To this path basically. So let's see what happens when we create this pod.
But at the end of the day, it's really just up to the backup client how they want to get hold of that token from the Kubernetes API server.
Yeah.
Yes.
All right, so we can see there's a CBT client job pod running. We'll quickly check if the service account token is mounted. All right, yeah, so we can see the token is generated and mounted here. So the same CLI that I had created for this demo, it also has these two flags, which will tell it to use the projected token. from this path. Okay. And if we other parameters are same, like source, the base snapshot name, target snapshot name, the application namespace, the client namespace, and yeah, rest of the parameters are same. If you call this, you can see if you go to the workflow, right? Yeah, so it discovers initial steps remain same to get the service address as well as sales certificate. We need snapshot metadata service, and we discover it based on the driver name. The difference here is instead of creating the service account token using the token request API, we are directly reading it from this path and using the token to call the gRPC endpoint on this address, right? So yeah, these are the two ways the client can use these APIs, and yeah, all the source code is here. In this repo, external snapshot metadata repo, we have server implementation as well as client implementation. We can quickly go over it, like, yeah, I mean,
Sorry.
from the logs, it's the flow.
Sorry, Prasad, just one quick thing. So for what it's worth, like one of the good things with the projected service account token is that like I'm pretty sure like the backup driver doesn't specifically need like an RBAC permission to call the token review the token request API. Whereas if you invoke the API directly, you need the RBAC permission. But with the projected service account defined the spec, like pretty sure that they don't need to specifically have the RBAC permission.
Is that
That's right.
okay? Oh, that's pretty cool. There's also another really good thing about it is that kubelet keeps that token alive. So so if you have a backup taking a long time, let's say something breaks and you restart using the starting offset, etc., just read a fresh token in and you're good to go. So
it automatically refreshes the token.
Yeah, one thing we got from the SigAuth group is like there are multiple ways to generate these tokens. Like even kubectl like has like a create token thing that for what it's worth user can use. So anyway, so basically the message is like there are many options to do the API to get a API server request token. In comparison to say previously, if we had to like roll our own like token management service.
Does this expire? Does it like expire
does.
automatically?
Yeah, it does.
it does.
But then there will be a new one will be generated automatically.
Well, so there's an expiry period you can specify, and but every time you read it from the file, kubelet will make sure that you get a fresh token if it's expired.
Yeah, if the backup server called it the token requests API directly, the backup server is responsible for refreshing it. But with the projected service account token, then kubelet would refresh it for the service account. So the backup software, it'll be seamless to the backup software.
Okay.
But again, these are just multiple options that the backup software can use. It doesn't affect the CSI driver per se. It's just many options for the backups client, which is the world that I live in. So this is like really good.
Yeah,
for me.
but still, yeah, those are those in the cap though? You talked about how that.
No, not really. I mean, I mentioned it briefly that you can use a projected volume, but this is a Kubernetes service, so people can go
Right,
in.
but it's probably still right for the completeness.
Okay.
I just mentioned you don't have to go into deep details, even including some links would be helpful.
Oh, there are a lot of links to everything. Yeah.
Okay.
Yeah, so as Evan mentioned, if you want to create token using token request APIs, we'll have to add these rules and bind these rules to the service account of the client, backup client, right? It needs access to this service account / token sub-resource. But yeah, with projected token, we don't need these specific permissions. We can quickly go to the service YAML as well.
So before that, does anyone have any question? Does anyone have any questions about the demo and the design so far before we dive deeper into the code? Does it make sense? Any red flags?
I think this is great, much better than the previous approach.
Much simpler too.
Yeah.
I think like I think we I just feel like finger crossed. I feel like we are at a point where we can just really scope this to be the alpha, release. And I know like there's still a little bit of requirements here and there, like what ifs here and there. But I think if possible, like if we can just say, hey, this is gonna be alpha, and anything else would be beyond alpha V1, that would be great. But anyways, Prasad, you wanna proceed?
I wanted to ask, how many organizations do we know of that are likely to implement clients and/or servers of this API, just as proofs of concept, right? Independent implementations, because that'll be the really positive signal when other people start using it and saying like, yeah, this works. So if we identify who those parties are, that'll help us get to the next step, I think.
Yeah, I can't speak for other organizations, but at least for us for Dell, like I live on the client side, so for us there's definitely the needs for it. And Tom, who's on the call, like he's like the CSI driver server side. I think he has some interest as well, right, Tom? In CBT.
Yep.
Yeah. So we'll be definitely, it definitely serves our needs if something like this become available.
Yeah. What I'm thinking is like once you have two different client implementations and two different server implementations, and you show that they all interoperate, like that's the gold standard, right? Once you get to that point, you'd say let's pour the concrete on this and say it's done. So I look forward to that, but please continue.
Yeah, since you mentioned about two different service implementations, so basically the sidecar implementation, the proxy service that we deploy as a sidecar, that will be common for all, that will be maintained by community. The service providers will, yeah.
I'm not talking about the community code. Yes, we want one copy of that, but you want to have like a couple of different vendors implementing like storage implementations of this, and a couple of different backup providers implementing client implementations of this, and showing that it all works. And then that's your sort of proof by example that it's the right answer.
Yeah. Cool. Anything else? All right. So yeah, I just wanted to quickly walk through the RBAC configuration for the external snapshot metadata service. For token to call token reviews and subject access review APIs, it needs permissions for the service account that this sidecar uses, needs these rules to be bound. The token reviews as well as the subject access reviews resources, along with, I guess, almost all the CSI drivers have permissions to volume snapshots and volume snapshot contents. Yeah, I mean, we can assume that it will already have this access. Additionally, we also need to add access, or we also need to add rules to provide access to snapshot metadata service resource. Other than that, I guess the permission to volume snapshots and PVCs that we can assume that almost all the CSI driver will have access already.
Yeah, the complete list of permissions is in the CAP. So, request, please read it and give comments on the thing, and including typos and, badly written code stuff. So.
Cool. Yeah, we can quickly go over the code. I guess the flow is from the logs and from the demo. I guess the flow is a bit clear, but I'll just walk through the code to reiterate over that. Yeah, when the client calls get delta RPC, right, of this proxy service, we have a get delta handler where we first perform the authentication checks. In the authentication, for authentication the request, we first discover the snapshot metadata service. We first discover the driver name. Yeah, for this service, it already has driver name set as a parameter or env variable, since it's deployed as a sidecar to the CSR drivers itself. But yeah, for the driver, we find out the snapshot metadata service where we get the audience stream, and then we call the authenticator to authenticate this request. And in the authenticator, we basically to jump to this. Yeah, we are calling token review APIs. So we use token and audiences as a parameter to this API, and based on the response, we return if the request with the token, with a given token, is valid or not. Once it's valid, yeah, once we make the token review API, we in the response we also get the user identity, which we return. And too much jump. Sorry about that. So we got the user info from the token review API, and we use this user info to perform the authorization checks. And in the authorization checks, what we do is we call subject access review APIs, and we do it to check if the user has access to volume snapshot resources. So we pass the verbs, like if it has access to get the snapshots, the volume snapshot namespaces, the GVR information, the user info, and yeah, and in the response we get the in response we get the whether the user is allowed to access the given resources in the given namespace with a given verb or not. So once it passes, the next stuff is sorry about that. Yeah. So the next step is next step is straightforward. We initialize the gRPC client. So since this is deployed as a sidecar, we initialize client with the Unix protocol, and the gRPC call is made over the Unix socket. So we call the CSR drivers endpoint. We call the drivers get delta RPC, and we stream the response back to the client here. So we have a the stream for we have a basically we are getting stream from the CSR driver, and we are sending it back to the CBT client. Okay, so it's kind of proxying the response from the CSR driver to the backup. I hope that makes sense. If you look at the client, we do we start from here. Yeah, so based on the parameters, right, we call setup security access. What we do here is we first find the driver name for the snapshot it has passed. Then we get the snapshot metadata service object for the driver, from which we get the audience, and then we create the security token. So if we have passed the flags like use mounted token. We read it from the file. Otherwise, we call creates service account token method, where we are basically calling the token request API with a given audience and given expiry. Yeah, in the response, we get the token, and we use that token then to perform the to call the gRPC endpoint to get the change block metadata. So here we populate all the parameters like security token, namespace based target snapshot names, and yeah, we make the gRPC call. We read from the stream till we get the end of file. Yeah, so this is the high level workflow, and we have, as I said, we have mocked the get delta RPC for the driver. And if you look at the implementation, it's again, we are doing nothing. We have implemented handler for get delta. We are just logging the parameters, and this is a mock response basically we are returning for each call. This is where the service providers will have to implement their own logic to get the change block metadata and stream the response back to the proxy service. Yeah, that's all I had to show. Any questions? Yeah, Dinesh.
Hey, Prasad. So this is my first meeting, so I apologize if any of this has already been discussed, but just looking at the design so far and the code as well. For background, I'm working on backup restore of VMs, which are surfaced in Kubernetes as custom resources. So a lot of this can also be generalized for other resources, but it looks like this is really specific for persistent volumes. There are a few references to volume snapshots, for example, in the code. So I guess my question is, early on, did we discuss to make it generic enough so that any backup server or backup provider can implement the, for example, get delta API and support CPT, for example? Because the technology is available for VMs as well, right?
Yeah, that's actually awesome. That's a very interesting point. I think it's possible, right? We can explore in future meetings, but essentially you saw Prasad's sidecar. Well, the sidecar is built over a library and the main program, right? We can always expose every piece of the code, and all the rest of the stuff is gRPC. So if you have a service which is gRPC, as long as you can connect to it, there's nothing in this design that stops you, that says it has to be a specific thing, like a snapshot or something. It's still abstract enough that maybe the discovery mechanism of how you discover the gRPC service can be tailored differently for, say, your use case.
Yeah, so I'll definitely go through the KEP in detail to see or try to spot anything that is specific here for volumes. But for example, I saw a few references of like volume snapshots, for example. So volume doesn't really map one-to-one for a VM, right? VMs have either disks or I'm sure they can have volume surface as well. But yeah, so those are the references that I'm talking about. They kind of tie this workflow to volumes specifically, which is fine if we have already discussed it, but I just wanted to raise this.
I think like so far we haven't discussed that, but like I think they are really like I think some part is generic, but I think some part will still be like specific to snapshots. I think, as you know, right, getting the deltas between the snapshots and the deltas of a VM, for example, is like the parameters, it will be different, right? Instead of like at this point, like instead of trying to like shoehorn it to fit like every single like potential storage entities out there, I think like the focus will be on snapshots. So, but like if you can help us to flash out like, like in order to get the deltas between like VM images, like this is what the inputs, parameters or requests will look like, then I think that would be definitely like interesting. But I think it's unlikely that we'll fold that, and it's unlikely that we'll make this cap like a be all and end all type of get delta for anything that you can think of type of API.
Yeah, I think this is the right primitive, to just focus on how do you get diffs of individual volumes and individual snapshots, because everything else is built on top of that, right? VMs can have multiple volumes and multiple snapshots, but a VM snapshot at the end of the day consists of volume snapshots and other stuff. And if you're trying to efficiently back that up, being able to go down to the individual volumes and get the diffs is extremely valuable.
Yeah.
So
but the VMs has static disks, and those are the part that cannot be included in this existing design.
what's a static disk?
Maybe Avinash can explain that.
So
I mean,
there are a few different types of disks that are available out there in the industry, disk types. So one of them are like a first class or individual disks, which can be managed or surfaced in Kubernetes as well. And their life cycle is not tied to the life cycle of a VM. And when Xing says static disk, that means a disk that comes with the VM and its life cycle is again tied to the VM. So if you delete the VM or if you snapshot the VM, that disk gets snapshotted or deleted with the VM.
but is there a CSI? Is there a CSI driver associated with that?
There isn't.
Okay. Well,
So I guess what I was referring to is like you mentioned snapshots, right? So yes, snapshots work for the VMs as well. And if this was generic enough that it was calling a snapshot API on a resource, which can be a volume or a VM or a pod or anything. Sorry, snapshots don't make sense for pods, but you get the idea. Any runtime engine. Then an implementation could be calling the volume snapshot or the VM snapshot. So not trying to derail, I need to go and read the cap, but that's kind of what I had in mind.
I just want to understand what snapshots a static disk today, if anything.
So nothing in Kubernetes yet. But if you have a VM, you can snapshot the VM. Pretty much every hypervisor supports that. And that is going to take a snapshot of the VM's runtime as well as all the disks that it has.
So Ben, basically when you take a VM snapshot, it includes not just all those PVC snapshots, but also the static part. That is not in a...
Yeah.
Well, what I'm hearing is, so the hypervisor has its own snapshot logic that doesn't rely on CSI whatsoever, right? Is that accurate?
Right, you can take a VM snapshot, which will snapshot everything.
Yeah, I mean, this proposal is for CSI, so like that's not CSI, so like that's not our concern. I agree someone should address it, but like for what we're trying to do is figure out for things that do use CSI, how do you make it better? And the answer is this proposal. You know, if they're not using CSI, there's nothing we can do, right? They have to go figure that out.
Right, just trying to see if this was, just trying to see if it was brought up early on. And so all of that exists at the hypervisor level. It's just a matter of if somebody tries to surface more like different types of runtimes at Kubernetes, VMs being one of them, how would data protection work for them? And I think that's a valid statement that this proposal focuses on just volumes that are managed by CSI. Which not every volume in a VM is managed by CSI. So that makes sense.
It creates an incentive so that if you do want to be able to take advantage of this kind of backup technology, to make all of your volumes CSI volumes, right? I mean, it creates a path for someone who's sufficiently motivated to go build the right system to take advantage of this. And anyone that doesn't implement it might get left out, right? That's always the threat of these new technologies is we're trying to encourage adoption by, influencing both the demand and the supply for the feature.
Yeah, so I see the logic there, but there's like, again, there are additional challenges that make it kind of impossible. Sorry, go ahead.
So Runesh, I think like the use case you define is valid in a sense. It's valid in a sense like there are folks on my team at Dell like who lives in your world, but I think for all intents and purposes for the scope of this cap, I think that is outside of the scope of this cap. Because the scope of this cap remain like CSI PVCs and CSI snapshots. Like when you said like backup or snapshot like the entire VM, I was thinking along what you said. It was beyond just all the CSI PVCs that are attached. It's like the actual entire image, entire state of the. So that is completely beyond the scope of this cap, as far as I'm concerned at this point. I think it's a good story, and there's a valid use case because we have people on my team trying to solve those kind of issues.
Okay, understood. So let me just go through the cap first, and then I'm okay with the fact that this is outside the scope of this cap. And we'll see how we can address it. Maybe in a different cap or some other design.
And for what it's worth, right? Even if your pod or containers is like backed by like Kata containers or gVisor or Firecrackers, if there is a way to CSI all the volumes of that thing, of that pod attached to it, then the implementation is up to that interface that Prasad showed, that get delta. At the end of the day, you have to write something, over that, so gRPC from client to CSI driver, and then another gRPC call from CSI driver over Unix socket to the plugin. At the end, you have to implement that get delta gRPC on the server side. So regardless of like whether you have back VMs or whatever, if there's a way to CSI it, then you have the flexibility to override and to write your own get delta implementation there.
Okay.
I think for I just want to be aware of time. I think like seems like there's no like glaring like red flag so far. I think we're gonna keep like keep the cap up to date, and then hopefully we can I guess whatever the right terminology is, opt-in for 1.29, is it? I think 1.28 is coming out in a week or 2 weeks, 3 weeks.
Yeah, I think next week.
August 15th.
We can.
And the cap. So is the cap accepted, or are we still working on that?
Well, I think we still need to get that approved, right? So Ben can help review the cap.
I was just going to say that the cap deadline is very shortly after the previous release. Like we only get a couple of weeks. So
I should update that, and then we can start reviewing.
We should push for that. This is at a stage where it's obvious that we should be pushing for the cap to be approved.
What about the CSI spec part? Do you need to do an update of that PR?
I think we do. That's pre-PR needs to be
that also
updated.
takes a very long time. But hopefully that one's not that complicated.
I think like Carl has been I think like Carl has been very detailed with all the gRPC spec. I think we can hopefully like copy and paste most of it from the cap into the CSI spec on PR.
Okay.
With maybe a little bit more details added to them.
So just so I understand, the CSI spec PR is not up to date today, but you'll fix that soon.
Correct.
Is that okay? That'll be great, because yes, that's another thing that needs to happen. That, as Xing says, it's not fast.
It takes a very long time. But I think the cap.
But I'm willing to help. So
that'll be great.
Make that update and tag me.
I think the cap needs to go in first, because the cap has a more there's a deadline that's written, right? So it's not like the CS spec one. We have more time. So make sure the cap gets in before the next cap freeze.
But the problem with trying to get the cap in before the CSI spec is done is it has to be a provisional approval. if you can get the CSI spec just done, then the KEP can just
Oh
be
no, we
approved, right?
when we sorted that last time with the modified volume, right? We initially think that's the case, but then we think it's okay. We don't have to block the KEP. KEP can be.
We don't have to block it, but like we have to approve it with an exception that, you know, if something in the CSI level changes, we have to update the KEP slightly. To match.
But you can do that later, right? So there is like
okay.
deadline come very early that we, you know, as long as you know how the CSS spec would roughly look like, if you are okay, right? We can merge the KEP first, and then
Okay.
Yeah, the thing that's why we did for the modified volume, because that KEP was merged a long time ago. The CSI spec was just merged, right, like a week ago or something.
Yeah.
Yeah.
We had a lot of very subtle disagreements. We got it all sorted out. So
yeah, that's good. Hey, sorry, I think we are on the top of the hour.
Okay.
So
thanks everyone.
right. Thank you. Bye.
Bye.
thank you.
Bye.